Okay, today's topic is on friction. So far we have been talking about friction in Newton's second law. And what we did in Newton's second law is we calculated the theoretical acceleration without friction, which is what Newton always based his observations on. And what we discovered in the second law lab is that there is always the presence of friction. And so we found the experimental error, and the experimental error revealed how much friction was associated with a cart being pulled down a lab bench. So what we're going to look at now is the idea of friction. So what is it? Some definitions that are involved with it, and also what's involved in what's called the coefficient of friction. So the types of friction are static friction. And what static friction is a force that prevents a stationary object from starting to move. So if you think of a box on a ramp, or if you think of a toboggan on a hill, right? A toboggan or a box sometimes gets stuck on a hill because of what's referred to as static friction. There isn't enough force or enough gravitational force to actually pull down the box or the toboggan, and so it stays stationary on the hill. Now, if you had the ability of increasing the hill height, or if a box was on a ramp, then if you could increase the ramp, what you're actually doing is increasing the gravitational potential energy. And so you get to the point where the box would actually start moving. And so this would be referred to as what's called starting friction. And it's the amount of friction that is needed to get an object moving. Now, once the object's in motion, the object will then start sliding. And when an object is in motion, then it is referred to as kinetic friction. Now, kinetic means moving. So you could have something like kinesiology, which is the study of moving, the body's movement. The study of kinetics. Again, that's another way of looking at studying the body's motion. Right? Kinematics is the study of motion. So kinetic means motion. And so we would take a look at that, and we're going to, kinetic friction is now the friction that's involved when an object is actually moving along a surface. So it is going from a stationary position, which is static friction, to a moving position, which would be now kinetic friction. Now, there's some key differences that you would want to keep in mind when we're talking about static versus kinetic friction. First of all, the force required to start an object in motion is much greater. So when we start an object going, it takes a much larger force to get an object to move than to keep it moving. So if we compare kinetic versus static friction, we would always say the force required for kinetic friction is much less than static friction. And we'll see that when we talk about frictional coefficients. Now, the other component that you wanted to be reminded of is that something that we talked about earlier in the unit is that when an object is in motion, so if I draw a free body diagram and we have applied force, the motion of that object, friction is always in the opposite direction to that motion. And so when we talk about kinetic friction, we always want to make sure that we know that whatever direction the object's moving, whether it's going uphill, downhill, or along a horizontal surface, we always define frictional force as the opposite to its motion. It is never defined as the opposite to its applied force or opposite to the tension force. Now, friction is has two really major components to it. So we are going to talk about mass, and then we will also talk about the surface. And those two things work hand in hand in order to determine how much friction is actually occurring in an object. So what we're going to look at, so we're going to draw a box here, and the box is the free body diagram. Now, in that box we have gravitational potential energy. So remember, gravity is mass times 9.8. Opposite to that, we have a normal force. Normal force, just to remind you, is perpendicular to the surface that the object's resting on. For this particular situation, we're going to have an applied force. That could be also replaced with a tension force. Opposite to that applied force, because it's on a horizontal surface, we would have frictional force. Now again, if we change the slope of this, that frictional force would change with the direction of the slope, not necessarily with the direction of the applied force. Now, when we talk about the coefficient of friction, we're really concerned about two key variables in terms of what's referred to as a ratio. So we're concerned with normal force, and we're also concerned with frictional force. And when we talk about a coefficient is the ratio between a normal force and a frictional force. Now, we also have to remember that our normal force is equal to our gravitational force, and that we can figure out our gravitational force by taking mass times acceleration. So to figure out what our normal force is, we can take the mass of the object, multiply it by 9.8, and we know, because it's on a horizontal surface, that it is going to be in the opposite direction of that with the same magnitude. Frictional force is going to be a ratio of that normal force to how much force is required to actually move the object. So, to summarize, the coefficient of friction is the ratio between frictional force and the force perpendicular to the two surfaces, which is referred to as our normal force. When Fa, so applied force, is horizontal, then we can assume the normal force is equal to the gravitational force. Now, this is a key component. You must remember that this is a horizontal situation. Things change when things go on a slant, so either an incline or a decline on a ramp. But in a question, or in a scenario where it states that it is horizontal, then we can always assume that that normal force is equal to that gravitational force. Now that's a very important point when we start looking at word problems. Now we have two situations when the applied force is in a direction that is not horizontal. So in one situation, which is looking at the red, we have an applied force that is pulling in an upwards direction. Now what that does is it changes the amount of friction that's involved in the system, because when we pull up on an object, it helps the normal force. And so the reality is that it actually makes less compressive forces between the surface. So it actually reduces the amount of friction. In the other scenario, so in the green box here, now we have an applied force that is pushing down on an object. Now when you push down on an object, try to push it across a floor, then you're increasing that pressure, and you're really actually increasing the amount of normal force because you're adding to the gravitational component. And so when you slide it across, it becomes much more difficult. And so the frictional force actually increases. So to recap, friction is reduced in the red free body diagram because the normal force is actually decreased, something that we'll focus on in our next class. In the green box, right, friction is increased because the normal force is also increased, because the normal force is just counteracting the addition to the gravitational force. So in the green box scenario, we have gravity pulling down, and then we have an additional force of the individual pushing down on the box. And so in order to keep it on that flat surface, we must increase that normal force, which in turn increases the amount of frictional force in the object. Now, in this case, we have our equation for frictional coefficients. So in the box that you see on your screen right now, you have the K's. Now the K's represent kinetic. And so what a coefficient of friction is a ratio between Fk, which is your kinetic friction, and your normal force, which is equal to your gravitational force on a horizontal surface. And what you end up getting is a decimal answer. And the decimal just represents a ratio. And that ratio really represents how much friction is present between those two surfaces rubbing together. Same thing applies for the second equation. The second equation is now looking at static. The S is representing static. Same thing applies. We have static friction, which is the Fs, and that is now in a ratio with the normal force, which again is equal to the gravitational force in a horizontal situation. So you'll get numbers, again, that look like this. So you might get a coefficient of friction of, say, 0.33. No units, just a decimal. Or you may get a number like 0.06. Now, the one with the smallest value, so the 0.06, indicates you have the least amount of friction. So this would be something like ice, right? Very slippery. Something with 0.33 might be going along a concrete surface. So a more rough surface will then create a greater coefficient. So to summarize, greater the number, the greater the coefficient, the rougher the surface, the greater the amount of frictional force required to keep the object moving. The smaller the number, right, the less friction is present, therefore less force is required to keep the object moving or to get the object moving. So again, the K represents kinetic, the S represents static. Static friction is always going to be greater than kinetic friction, something that we talked about in a previous slide, something that you should keep in mind when you look at coefficients of friction. Now, we're going to go through a couple example questions. So in this example question, we have Frank. Frank's pushing a box across the floor. Again, we assume horizontal application of force towards the north end of the building. If the kinetic friction is 20 newtons and the box has a mass of 15 kilograms, what is the frictional coefficient of the system? Well, again, we always look at the given. So we know frictional force, that's 20 newtons, right? That's established in the question. The mass of the box is 15 kilograms. Well, again, we assume horizontal surface, so we assume that our our normal force is equal to our gravitational force. So we can take Fg, which is gravitational force, multiply it mass times acceleration, and we're going to get 147 newtons. So we now know that our normal force is 147 newtons. We then go into our coefficient equation, and we're going to take our frictional force, right, or our kinetic friction, and then divide that by our normal force, or really finding the ratio between our force of friction and our normal force. And then we're going to get a number of 0.14. And that would be your final answer. 0.14 is the coefficient of friction in that particular situation, in those particular surfaces working together. Second example, we have a cyclist who applies brakes and starts to skid on a dry asphalt pathway. If the bike and the rider's combined mass is 80 kilograms, determine the kinetic friction. Now, in this one, I want you to open up your textbooks and you're going to look at page 101. On page 101, you're going to get a list of coefficients. In that list, you're going to get a list numbers that represent kinetic friction, and you're going to get numbers that represent static friction. So again, you have to determine what kind of situation is occurring in the question. Now, in this particular case, we have kinetic friction happening. So we're going to find out the coefficient of kinetic friction. So again, we look at the given. Now the given, we know mass is the 80 kilograms. So that's the bike with the rider. The kinetic friction is 1.07. Now that's looking at the chart on page 101. And the chart on page 101, if you look at rubber on dry asphalt, then you're going to get a coefficient of 1.07. Now that's quite high, and that would make sense because when you skid rubber on asphalt, you slow down quite quickly. So there'd be a lot of frictional force there. Then, when we look at the situation, we want to figure out our normal force. So again, it's a horizontal applied surface, or applied force on a horizontal surface, rather, sorry. Our normal force is going to equal our gravitational force. So we're going to figure out our gravitational force, which is going to end up being 784 newtons. Now, we're going to take our coefficient of friction, and again, we're looking at the ratio of frictional force and normal force. We know, in this case, the coefficient of friction already, which is 1.07. And we already know that our normal force is 784 newtons. We rearrange that to find our frictional force, and it's going to come to 840 newtons. So, giving you a couple example questions. Now what I would like you to do is look at the next slide, which lists 6 questions in your textbook. The answers are provided in the textbook already. It will give you some guidance. There's some sample questions there as well. You want to take a look through them. Make sure that you're on the right track in using the idea of a frictional coefficient. So for next class, which for some of you will be on Thursday and some of you will be on Friday, you want to have taken notes on this PowerPoint presentation. I will want to see a series of notes outlining all the key topics that we covered in this presentation, and I want to see the homework completed. From there, then we're going to be able to discuss 3 or 4 key ideas from there. I'm going to ask some questions that's going to allow you to summarize what frictional coefficients are, which then will allow you to be able to work more effectively on the inquiry lab that we're going to start that day. All right, so that's it for frictional coefficients and the idea of friction. We'll see you at class.